Welcome to Beyond the Visible, a visual journey, where we embark on an awe-inspiring exploration of the universe through the lens of the James Webb Space Telescope. This revolutionary instrument has not only captured breathtaking images of distant cosmic wonders, but has also ushered in a new era of scientific discovery. Today, we'll delve into the captivating science behind these mesmerizing pictures and uncover the groundbreaking insights they provide. As we begin our journey, let's feast our eyes on one of JWST's most iconic images, the Carina Nebula. This vast stellar nursery, located approximately 7,600 light-years away, appears as a swirling tapestry of gas and dust. But there's more to this image than meets the eye. The telescope's infrared capabilities allow us to peer through the cosmic dust, revealing previously hidden newborn stars and planetary systems in the making. The Carina Nebula image exemplifies JWST's ability to see beyond the visible spectrum. By detecting infrared light, the telescope can observe objects and phenomena that are invisible to optical telescopes like Hubble. This breakthrough technology enables scientists to study the earliest stages of star formation and planetary evolution with unprecedented clarity. Moving deeper into space, we encounter the Stephan's Quintet, a group of 5 galaxies locked in a cosmic dance. JWST's image of this galactic gathering is not just a pretty picture, it's a treasure trove of scientific data. The telescope's instruments have allowed astronomers to study the interactions between these galaxies in exquisite detail, shedding light on the processes that shape galactic evolution. One of the most exciting aspects of this observation is the detection of shock waves caused by one galaxy smashing through the cluster at high speeds. These shock waves, visible as glowing gas in the image, provide valuable insights into the dynamics of galaxy collisions and the formation of intergalactic material. But JWST's capabilities extend far beyond our local cosmic neighborhood. Let's turn our attention to one of the telescope's most groundbreaking discoveries: the observation of the most distant galaxy ever detected. This ancient galaxy, seen as it appeared just 300 million years after the Big Bang, is pushing the boundaries of our understanding of the early universe. The image of this distant galaxy may appear as a tiny red speck, but its significance cannot be overstated. By studying objects from this early epoch, scientists can piece together the story of how the first stars and galaxies formed, illuminating a previously dark chapter in cosmic history. JWST's infrared vision is particularly crucial for observing these early galaxies. As the universe expands, light from distant objects is stretched, shifting visible light into the infrared part of the spectrum. This phenomenon, known as redshift, means that the most distant and ancient objects are only visible to infrared telescopes like JWST. Another area where JWST is making significant strides is in the study of exoplanets. The telescope's precision instruments allow it to analyze the atmospheres of planets orbiting distant stars, searching for potential signs of habitability or even life. One of JWST's most exciting exoplanet observations to date is of WASP-39b, a hot Jupiter-like planet located about 700 light-years from Earth. The telescope's spectroscopic capabilities have revealed the chemical composition of this planet's atmosphere in unprecedented detail, detecting the presence of water vapor, sulfur dioxide, and even evidence of clouds. While WASP-39b itself is unlikely to harbor life, these observations demonstrate JWST's potential to study the atmospheres of smaller, more Earth-like planets in the future. This capability brings us one step closer to answering one of humanity's most profound questions. Are we alone in the universe? As we continue our visual journey, let's explore JWST's observations of our own cosmic backyard. The telescope has captured stunning images of Jupiter, revealing intricate details in the gas giant's turbulent atmosphere and its faint ring system. These observations not only showcase the beauty of our solar system, but also provide valuable data for planetary scientists studying the dynamics of gas giant atmospheres. JWST's study of Jupiter extends beyond the planet itself. The telescope has also observed Jupiter's moons, including Europa, which is believed to harbor a subsurface ocean that could potentially support life. By analyzing the infrared spectrum of Europa's surface, scientists hope to gain new insights into its composition and the processes occurring beneath its icy crust. One of the most visually striking images produced by JWST is that of the Southern Ring Nebula. This cosmic butterfly, as it's often described, is actually a dying star shedding its outer layers. The telescope's infrared vision reveals intricate details of the nebula's structure, including shells of gas and dust that were expelled by the star over thousands of years. But this image is more than just a cosmic work of art. It provides valuable information about the life cycles of stars and the processes that enrich the interstellar medium with heavy elements. By studying objects like the Southern Ring Nebula, astronomers can better understand how the raw materials for planets and life are dispersed throughout the galaxy. JWST's observations are not limited to distant or dying stars. The telescope has also provided new insights into star formation by peering into stellar nurseries like the Orion Nebula. These images reveal the turbulent environment where stars are born, showing us the delicate balance between gravity, radiation, and magnetic fields that governs the birth of new suns. One of the most exciting aspects of JWST's mission is its potential to detect biosignatures in the atmospheres of exoplanets. While we haven't found definitive evidence of life beyond Earth yet, the telescope's ability to analyze the chemical composition of exoplanet atmospheres brings us closer to this monumental discovery. Imagine a future where JWST detects the presence of oxygen, methane, and water vapor in the atmosphere of a rocky planet orbiting within its star's habitable zone. Such a discovery would be a strong indicator of potential biological activity and would revolutionize our understanding of life in the universe. As we near the end of our visual journey, it's important to remember that each image and data point collected by JWST represents a collaborative effort involving thousands of scientists, engineers, and technicians from around the world. The telescope is a testament to human ingenuity and our insatiable curiosity about the cosmos. The James Webb Space Telescope is more than just a machine for capturing pretty pictures. It's a time machine that allows us to peer into the distant past of our universe, a detective uncovering the secrets of planetary formation, and an explorer searching for signs of life beyond our solar system. As we continue to receive and analyze data from JWST, we can expect many more groundbreaking discoveries in the years to come. Each new image and observation has the potential to rewrite our understanding of the universe and our place within it. In conclusion, the James Webb Space Telescope represents a new chapter in our cosmic exploration. Its stunning images captivate our imagination, while the science behind these observations pushes the boundaries of human knowledge. As we gaze upon these cosmic wonders, we're reminded of the vastness and beauty of the universe, and our own remarkable ability to unravel its mysteries. The journey of discovery has only just begun, and the best is yet to come.